Robert Albach is the product line manager for IoT security at Cisco. In that role, he's responsible for industrial security planning within the firm's security product portfolio. He joined Cisco in 2010, and since his joining Cisco has delivered 3 network security solutions, with the most recent being Cisco's first industrial security appliance. Prior to joining Cisco, he guided development of IPS solutions for Tipping Point, which, as we all know, is a pioneer in that segment. And he has also led product management efforts in application management at IBM Tivoli, BMC, and Quest Software. Let's welcome Mr. Robert Albach.
Good morning, and thank you for attending this morning and listening to me. Just first thing up front, that's my email address. I would not have put it out there if I didn't welcome you to contact me, so that's ralbach@cisco.com. And so we're going to tell a few stories here today, but for the most part, I think there's a big point I'm going to let you know is that what I'm going to discuss today is not going to have anything to do with your webcams or your DVRs or anything that you embed within a teddy bear and give to your kids. My focus is industrial security, specifically heavy industry. So things where you need steel-toed boots and stuff of that nature, things where a free credit check and a background isn't going to help you if things go south. All right, so Austin, Texas. As such, I'm probably going to be referencing a whole bunch of energy things because it's Texas for gosh sakes. And what else do we do there other than that? And let's go forward. Let's see how we're doing. First of all, we're going to start with the Ukraine utility attack. There were 2 of those. Is everyone familiar with what happened in Ukraine the last couple Christmases, effectively? All right, 2015, somebody makes their way into the control environment. They initiate some activities. About 250,000 people lose power for roughly about 4 or 5 hours, but then degradation of the systems takes place for a long time. It was a really cool attack if you really kind of take a look at all the stuff that was done. It was pretty interesting stuff. But for the most part, what we're going to start with is, this is actually a screen capture. And if you go to wired.com, you can actually watch this video. It's a video. Now, the guys are speaking. It's actually recorded on an iPhone. They're speaking Ukrainian. You probably don't speak Ukrainian. But what's happening here is they're on this desktop, and this desktop is basically the control system. If you look at this fairly closely, you'll notice immediately it's a Windows box, okay? They're filming what's going on. They have no access. They can't control what's happening. They're basically frozen out of the box. The guy's moving around. He's going in, and basically he's at some substation controls, and he's going to flip breakers. You flip breakers, you basically disconnect. Electricity doesn't flow anymore, all right? Simple enough. So these are the control guys. They're filming this. They don't know what's going on. But they're like, well, actually, they know exactly what's going on. They just don't know who and what's going on. So they're obviously concerned because they know someone's turning off the electricity. And they basically, one of the comments made is, hey, we should contact the IT guys and let them know what's going on. Well, what if it's the IT guys doing this? All right? So that's my first little point. There are organizational and social issues associated with industrial environments. If you are an IT person, they don't want you within 100 miles of their stuff. Their assumption is you're going to screw it up. And let me just make the statement. IT security departments have shut down entire factories by accident. That's why they don't trust you. Because the means by which compute, network management, and security needs to operate in these environments is very different from everything you're probably being taught now, for those of you that are students, and those of you that are actively engaging in IT security within your IT environments. It's just flat out different. And thus the attitudes that you're dealing with are going to be very different as well. So attitude number 1, we're here talking about security. The concept of security is very different in the industrial world. We think of it sort of as locks. From their perspective, it starts with the hinges on the door. Okay? Question. When we started this meeting this morning, or let's just say yesterday, at what point did someone tell you where the AED was, where a fire extinguisher was, or if something goes bad, where we're all supposed to go meet? It's very rare that I have a meeting with an industrial customer where every meeting doesn't start off with that discussion point. How many of you walked up the stairs? How many of you had your hands on the rail when you walked up the stairs? Okay. In these environments, when I walk downstairs multiple times, I don't put my hand on the rail. Every time I get stopped in the middle of that staircase and told to put my hand on the rail. Safety is everything. Okay? So the concept of security does not start and end with the 400-pound hacker wearing a hoodie. Okay? So this is what happened in the Ukraine, a pretty big event. All right? This was a big event in the Ukrainian power history. There was another one 29 years earlier at a place called Chernobyl. Yes, people did lose power for 6 hours in 2015. On the other hand, you can't get within a mile of this place for the next 20,000 years. What was the bigger event? The hack or the simple error? Because it was a simple error that someone did. The concept of security in this case is I need to keep the system secure, and it doesn't matter whether I did something on purpose or by accident. What's the difference? The purposeful thing knocked out power for 6 hours. The accident, you can't walk in there for 20,000 years. That's their scope and concept of security. So it's a very different type of approach. And thus, you have organizational concerns, and thus you have cultural concerns that you have to adjust to if this is your responsibility of securing these types of systems. All right, so let's move forward a little bit on some of the challenges. Again, we'll start with the following. The age difference between industrial and non-industrial workers doubled between 2000 and 2012. People are not going into the classic heavy industries anymore. You remember those ads that GE had where Owen's graduating from college and he's going to go work for GE and all of his friends are bummed for him? Right? His friend's going to go work at some startup that's going to make a little app on your iPhone that puts, fruit on top of cats' heads or something? Okay, this is a very real issue. It is very much an issue associated with more modernized industrial environments. It's a big deal in Germany. It's a big deal in Japan. It's becoming a big deal in South Korea and Taiwan as well to some extent. The fact of the matter is people are opting not to go into the heavy industries. And as a result, the people who have been building out the systems for the last few decades are reaching retirement age. And then you've got a whole new slew of people that are somewhat following in and just connecting these things without truly understanding the pre-existing systems. Okay. The number of TCP-connected endpoints in industrial environments rose 96% between 2011 and 2015. If we were talking about a third world country where we were introducing smartphones, that's the kind of numbers you would see. Instead, we're talking about well-established 100-plus-year-old companies that are doubling the number of TCP-connected endpoints. And effectively, this is happening within the industrial environments. The industrial environments that were built up and known by people who are now reaching retirement age. Thirdly, the number of vulnerabilities found in industrial systems rose 2,400% between 2009 and 2015. The things that operate these industrial equipment are effectively designed without real security concepts. Another story, there was a mention that I worked at Tipping Point. 2007, 2008, I was working with a gentleman by the name of Ganesh Devarajan. I think Syracuse is here. He's a Syracuse grad. And he went to a DEF CON. He had a fuzzer, and he was basically fuzzing industrial protocols there. A lot of people were really angry about that. We had a call with arguably one of the largest manufacturing automation firms. They threatened to sue me personally if we published previously known details about vulnerabilities that existed within their products. Right. This was a very large company coming to this little startup company, pointing directly to me and say, you have just made a decision, that was a personal decision of yours, and we are now going to sue you. This was details already known. Point being, the organizational and the cultural concepts of exposing vulnerabilities in public environments was not at all welcomed. Things have improved, but they haven't improved hugely, but they've gotten better. But the point is, we had a cultural issue. The fact that someone would publish previously known information that could be found in the public environment on a vulnerability for an industrial system was basically something they thought they could address through the legal system. Nor did they understand that the concept of the Streisand effect. Who knows what the Streisand effect is? Just a few of you? Oh, goodness gracious. Barbara Streisand. Butter. She had a house on the California coast. Someone took a picture of it to show erosion. She tried to go to the courts to have that picture stopped. Suddenly, that picture, which may have been present on one place in the internet, was present in like 10,000. The more you try to suppress information, the increased probability that you are, in fact, going to expose it. That's the Streisand effect. And that's exactly what you're dealing with when you're talking about security researchers. You tell them to keep something quiet, you guarantee it just went the opposite direction. All right, the minimum technology horizon for refresh is at least 5 years, minimum of 5 years. So assume that something that was put into place 10 years ago is probably humming along perfectly fine. Why change it? One of the reasons why there is so much XP out there controlling the fact that your light's on right now. All these things you see here, with the possible exception of vulnerabilities there, none of these are technical issues. But the fact that you've got systems built by people that are retired, they're not getting replaced, they're getting connected at a high rate, and they're incredibly vulnerable is just a bad combination of things. That's what you're dealing with. Now, another attitudinal issue. This ISA 99 is the basic reference standard for building out industrial environments. It has an equivalent called IEC 62443, but the point to look at is when it defines the role of security, the role of security is defined in a negative definition. Security won't cause problems. That's what they think of security. Hi, we're from the security department. We'd like to put some inline devices here to inspect your traffic and control access. From their perspective, that's a threat. And they're not totally wrong. If I've got a truly real-time environment here in which I have to coordinate the US grid, right? All of the electrical providers are kind of interacted next geographically, right? You are running electrical equipment, basically every 60 seconds you've got cycles going on. I mean, every 60th of a second you've got a cycle. You have to coordinate that with the guy next door. So imagine, how do I coordinate that phase difference where we interconnect, right? That's real-time types of stuff. I think I'd like to put some packet inspection thing between those two. That's a danger. In some cases, introducing security makes the system less secure. The concept of security being the system will continue to work in a fashion that nobody dies. All right, so again, it's an attitudinal, organizational difference, comprehension of what does security mean. So let's take a look, and this is a very unscientific view of certain vertical segments. On the far side, the area I'm focused on, utilities, manufacturing, to some extent transportation. At the far left side, you've got things like retail and healthcare. We have, again, very unscientific, but we've organized IT types protocols and compute tools with OT, operational technologies and protocols and such. And so what you'll see is on the far right, we've got utilities and digital environments with a lot of computing things, talking things, communicating things that are not using standard IT types of tools and technologies. Serial communications, PLCs, things with the unfortunate acronym of IEDs. As you move over, you get to the healthcare environment. Things for the most part, everything's TCP/IP. Yes, it may be something unusual like an X-ray machine and MRIs and so forth, but the thing that controls it's going to be a Windows box, and it's going to connect probably through TCP/IP. Looks pretty standard stuff. On the other side, I've got, again, serial communications. As I was educated on one of my first early visits to a utility, Mr. Albach, we understand Cisco, they're a wonderful company. You guys have done amazing things for the internet, but please consider 50 years before the establishment of Cisco, we were monitoring and maintaining electrical equipment hundreds of miles away remotely. Point being, you thought you invented the WAN. We think we did it in the 1920s. So check the attitude at the door. Come in and understand that these guys have been doing some very interesting things with remote monitoring and control of equipment for a very long time. And that, to some degree, is part of the challenge. It worked perfectly well in the 20s. You didn't need to make a whole lot of changes as things went. So utilities were probably arguably the first long-distance remote monitoring, remote control thing out there. Automated development. Right outside of, you got Automation Alley, just outside on the Detroit. You've got a lot of automated development and manufacturing environments. Worked perfectly fine, continues to work fine. As such, they've felt no real compulsion to make a whole lot of wholesale changes to the basic compute and communication models and other such as there. So, first moves over disadvantage. Over on the other side, connected retail, healthcare, that's much more recent that they started taking equipment and actually connecting it and having it controlled in that fashion. And because it came later on, they adopted the more recent technologies. So these are parts of the challenge that are largely at play. Let's reference a electrical environment here, and this is just on the transmission side, not on production. At the top level in gray, you've got the control area. You've got things like an operations center and a data center. All the telemetry that's being generated in that environment gets pushed up there, and you can take a look at what's going on. That's, for the most part, a bunch of IT technologies. All right? Some of it may be outdated, not at all uncommon, but it's IT-looking stuff. Hence, it's the IT-looking stuff that controls the operational stuff. Down here, you have the electronic security perimeter. Increasingly, that's getting connected through IT technologies, but to a large part, often it's using some different sets of protocols at play, serial connected things, if you will. In some more modern environments, you may have some IP phones, you may have remote cameras being connected. Here's an interesting concept. How many of you associate physical security with your network security concept? I badge into a room, true or false? I should only be logged into equipment in that room. How many people currently associate your network security with your physical security? It's kind of rare, all right? Doesn't happen often enough. Needs to happen here as well. But the big point here, as in with that Ukraine example, the control environment is Windows boxes. There is no need to go off and learn special funky stuff associated with the operational technology. You could invest a lot of time and do that. I could figure out how to create things that attack the PLC or the RTU, if you will, but why do that when I've got garden variety Windows tools that will help me take over the control systems and launch the attack from there? Remember that picture I had up front? That was a Windows platform. Oh, and by the way, one of the ways they got there was through remote desktop protocol. And by the way, that remote desktop protocol was actually the tool of the IT department. So in a way, yes, it was the IT department. The IT guys got hacked. They used the IT tools to get to that equipment, and they just manipulated as they needed to. All right, every network has got its own challenges. IT networks, things are fairly dynamic. You folks walked in here with compute things. You're going to walk out and go somewhere else and connect to some other network within the day, guaranteed. On the operational stuff, not quite so much. Things are a lot more fixed. You've got a lot fewer applications. I have more applications on my laptop than are actually within an entire assembly line at GM. It's fairly fixed. It's fairly stable. Big clue, if you can put your network and process design in a piece of metal and have it be representative, that's probably going to be an OT network. Things are different in some of these environments. How do you set an IP address there? It's not necessarily DHCP. You go out with a screwdriver. You go find that switch in the device. You start turning little dip switches. And then you close it up, and it's pretty well set. So again, it's a different world. The way you manage these things, the way that you provide security is very, very different. How do you paint a car? The process of painting a car at least one plant is about 4 kilometers long. There's 90 different robots at play. There's 16 different stations. Here's another organizational difference. Each of these stations come from about 6 different builders. All right? Think of this as a subnet, and a subnet that performs a particular unique function. All right? So there's a treatment point. We come in and we wash all these things. We get all the grime off, whatever. That's somewhat automated. We then put electrocoat on it. It goes into an oven. We heat the oven. It comes out. We now do some sanding and so forth. The oven is built by Owens Oven Company. The sanding is built by Sandy's whatever. They build the whole thing. They test it in their lab. I shouldn't say their lab, in their garage. They bring the thing on a pallet. They plop the thing down. You plug into the network. Owen has produced, in this case, 5 different ovens. Each one of them, all the equipment in, has the exact same IP address. The contract with Owen says, thou shalt not change anything in there. All right. Sandy's sanding spot happens to have a nice cellular modem into it so that they can get feedback directly over the cellular system, thus bypassing any and all possible security that your company might want to have applied there. Contract says you can't go in there and change that. These are the organizational constraints that you're often dealing with here. And as such, your concept of security becomes very different because there are, in fact, robots here. And these robots basically often work within close proximity of humans. If the robot is feeling a little arthritic and maybe it's not getting the full range of motion, someone initiates a kind of debug program. Arm goes out fully. We extend it 360 degrees at a rapid pace. Maybe there's a human standing there, maybe not. Again, the concept of security is very different within these environments. So a lot of this is basically driven by the organization. It's driven by their history. It's driven by the relationship between the IT group and the OT group. In the majority of these operational environments, all the networking, all the security, if there is any, is going to be funded by the operational guys, right? Meaning General Motors builds cars. Guess who's in charge? The security department or the guys who build cars? The guy who builds cars gets to say, well, how many fewer cars do you want because we're going to be introducing all these security systems instead? The answer is rarely a positive one. So it's organizational, it's economics, it really determines these things. It's just a different world. Again, check your ego, check your past experiences at the door, walk in, learn, and learn some more. And then you come in and figure out where it is that you can add value and how it is that you can help. All right, so with that, I don't know how we are in time, but if nothing else, you've got my email address, robertalbach@cisco.com. Time for questions or no?
Probably would take them off to the side again.
Off to the side, and I don't know which side we're going to take them off to, but I'm going to go out that door. And if you do have questions, I will be out there waiting for you. So thank you very much.
Thank you.